The question is, consider the digraph shown, directed graph. There are multiple shortest paths between S and T. Which one will be reported by the Dijkstra's algorithm? Assume that the shortest path to any vertex is updated only if a strictly shorter path is discovered. So if you discover two paths are of the same length, it is not updated. So the graph is shown. We have to find which path from S to T Dijkstra's algorithm will report. Option A, SDT. Option B, SBDT. Option C, SACDT. Option D, SACET. So one thing that is confirmed is that Dijkstra's algorithm will report the shortest path between any two vertices. So if you notice SDT, S to D to T, the length is 7 plus 3, 10. So this is 10. SBDT is 3 plus 4 plus 3, which is again 10. SACDT is 4 plus 1, 5 plus 3, 8 plus 3, 11. So you can be very sure option C is eliminated directly. SACET is again 4 plus 1 plus 1 plus 4, which is 10. So it can be any of A, B or D. You can just eliminate option C. Now the Dijkstra's algorithm, basically you follow the concept of discovered vertices. Initially you know only the distance from S to itself. The distance from S to every other vertex is infinity. So next you update the neighbors and you set S as their predecessor. So the distance between S and A is now set as 4, S and D is now set as 7, S and B is now set as 3, and the predecessor of A is now S, predecessor of B is now S, and predecessor of D is now S. And the predecessor of everything else is set to -1 as it is not discovered yet. And the distance of these nodes are also updated. So distance of A will become 4, distance of B from S, that we are calculating only from S here. So distance of B from S is 3 and distance of D from S is 7. Next is, of these distances, you take the least one, the node with the least distance, and explore its neighbors. So here B is the least distance, 3. Now you explore its distances, its neighbors. So B's neighbor is D, and now the distance from S to B is 3 and B to D is 4, which is 7 again, which was the original distance anyway. So initially it was 7, now it's 3 plus 4, which is 7 again. So it is said that the shortest path to any vertex is updated only if a strictly shorter path is found. So the predecessor of D is not changed, it is still S. So now B has only one neighbor, the other neighbor is S itself. So initially the distance from S to S is 0. So you don't update that at all. Now the next shortest of this is A. Now you will discover A's neighbors. Here A's neighbor is C. Now that is discovered. And the distance from S to C is 4 plus 1, 5. Distance of C is 5. And predecessor of C is A. Now we have checked B's neighbors, we have checked A's neighbors. Now out of these two, C is the smallest. You will check C's neighbors. So C's neighbors are E and D. And now distance of E, you calculate distance of E. Distance of E is existing distance to C plus that path. So existing distance is 5 plus 1, which is 6. And distance to D is 4 plus 1, 5 plus 3, 8. Which is greater than 7, so you don't update it. So you update E's neighbor. So I mean E's predecessor. So predecessor of E is C. Now we have checked C also. Out of the remaining D and E is the smallest. So you check E's neighbors. E has only one neighbor, which is T. So distance of T is existing distance, which is 6, plus this length, which is 4, which is 10. So, and G, distance of G is existing 6 plus 2, which is 8. And you set predecessors. So predecessor of T is E, and predecessor of G is also E. Now we have reached our destination, required destination. We are reported to find the path which is reported by Dijkstra's from S to T. Now we have reached T. So the path taken is, we have reached T. Predecessor of T is E. So put it before predecessor. Predecessor of E is C. Predecessor of C is A. And predecessor of A is S. So this is the path taken, which is option D. So this is the path that will be reported by Dijkstra's from S to T.